Okay, for 5.3, we're going to talk about points of concurrency. So we talked about bisectors, perpendicular bisectors in a triangle, and we talked about angle bisectors in a triangle. So today we're going to talk about what happens when those bisectors actually meet together. So if you look at the first couple of vocabulary words, we say when three or more lines intersect at one point, we say that these points or these lines are concurrent, and the point at which they intersect is the point of concurrency. So the first point of concurrency that we're going to look at is the point of concurrency for the perpendicular bisectors. Okay, so if you look at this diagram right here, what you'll notice is that if we draw the perpendicular bisectors for triangle ABC, they are concurrent at point P. Okay, what happens when we have this concurrency point at point P is that it creates bisectors, or actually creates congruent segments right here. Okay, and these congruent segments go from the point of concurrency to the vertices. And what we'll notice is that if we draw a circle around this triangle using the point P as the origin and use these segments that were created from P to the vertices as our radius, we'll circumscribe the triangle with a circle. So the point of concurrency that we're talking about, point P, is called the circumcenter of the triangle. And when we draw this circle around the triangle, it's said to be circumscribed about. So drawing the circle around is to circumscribe. We do the circumcenter, or the perpendicular bisectors for the triangle. In an acute triangle, this circumcenter occurs inside the triangle. In the right triangle, it occurs at the midpoint of the hypotenuse, and in an obtuse triangle, it occurs outside the triangle beyond the longest side. Okay, so if we're going to find the circumcenter of the triangle, the very first thing that we need to do is actually graph the triangle. So we take these points right here. We'll say point P is going to be at 0, 6. We'll say that point O is going to be at 0, 0, and that point S here is going to be at 4, 0. So to find the midpoint of the vertical and horizontal side are very simple, because we'll just count them. 1, 2, 3. That'll be the midpoint for that one. And since this was on 4, it's going to be at 2. Okay. And in order to draw the line that's going to be perpendicular to these, again, since it's going to be an undefined line for the horizontal for OS, and then a slope of 0 for this one, it's fairly simple for us to get the perpendicular line drawn for these. Okay. What happens though is, as we move into drawing the perpendicular line to the hypotenuse for this particular triangle, it's going to be a little bit more difficult, because it is a sloped line. So the first thing we have to do is find out what is indeed the slope for this line, PS. Okay, so we'll take point P and point S, and we'll say the change in y. So we'll say y2, so 6 minus 0, and then x2 minus x1 would be 0 minus 4. And it looks like we'll get negative 6 over 4, or 6 over negative 4, which will turn into negative 3 over 2. So in order to get the perpendicular slope for that, we would say the perpendicular slope, or the line with a perpendicular line, would have a slope of 2 over 3. Okay, the next thing we need to know is, what is the midpoint? Okay, so in order to find the midpoint, we'll use the midpoint formula, x1 plus x2 over 2, and then y1 plus y2 over 2 to get the coordinates of the midpoint. So again, you're going to end up with 4 over 2, 6 over 2. So it looks like the midpoint is going to be 2, 3. So I'll go 2, 3, which actually ends up being right where I want it to be. And then I will count backwards to find the slope, or either count forwards. I need to find another point to get the slope. So that would be up 1, 2, and over 1, 2, 3. Okay. And now that I have the opposite slope and the midpoint, I can extend my line through the hypotenuse. Okay, and from there, I should be able to tell what the circumcenter is for this particular triangle, because again, the circumcenter will be the point where all of the perpendicular bisectors meet, and this is going to be that point, and that point is 2, 3. Okay, so take a minute and try this triangle ABC and see what you get. Okay, so if you found the opposite slope for all of these in the midpoint, you would see that the circumcenter comes through at 6, 5. And the pattern you should notice here is for both of them is that the circumcenter is going to occur at the midpoint. So the circumcenter is going to be at the midpoint of the hypotenuse for right triangles. Now, that's not going to be true for every triangle, but that is going to be for right triangles. Okay? So the next point of concurrency we need to talk about is the angle bisectors. So when we have a point of concurrency for all angle bisectors, they will meet again here at point P. And what you'll notice is that it will create congruent perpendicular segments to the sides. Now notice these perpendicular segments are not segment bisectors, right? They don't bisect the actual sides. They are perpendicular to the sides um, from point P. And what happens if you look down here is that at point P, what we have done is we've created these radius, or radii. So instead of having the circle go around or circumscribe the triangle for this particular example, the circle is inside, so it's inscribed. Okay, and so the point of concurrency for all the angle bisectors is the in-center, and P, or the point of concurrency, the in-center becomes the center or origin for the inscribed circle, so that the circle is now inside. Now, if we use this particular piece of information, that these have these congruent perpendicular segments, we can use it algebraically to find missing pieces. So the first thing I'm going to notice is if G is the in-center, then I know that GD is congruent to GE, which is also congruent to GF. So knowing that piece of information, I can say that 2x minus 7 is equal to x plus 4. If I solve algebraically, subtract x from both sides, I will get x minus 7 equals 4. And of course, my next step would be to add 7 to 4, and x would equal 11. It actually doesn't ask me for x, so I'm going to need to plug it back in. So I'm going to say if 2 times 11 minus 7, okay, gives me 22 minus 7, 15. And then I'll say 11 plus 4 is also equal to 15. So now I've checked it. That gives me GE is 15. It tells me that GF is 15. So therefore I know that GD is also 15. Okay? So we'll use the same information to find out what QO is. So go ahead and work it out and then check. Okay? So I use the same information and assume that Q is the in-center of triangle JKL. That gives me that QO, QN, and QM are all congruent. So solving for x and plugging back in, I find out that QO is equal to 61. Okay? So go ahead and work the following problems. When you get to the finding the coordinates, just do 9, 11, and 13 just to save some time, and then work through to 18. And we'll check them together on Tuesday. Sorry, we'll check them together on Tuesday.